So I will do this fall 20 test 2 first for number 1. Again, if you have any specific question you want me to go over, just let me know. Okay, so that I don't need to go in order. Number 1 here, integrate in x minus 2 over x cubed plus x squared. That's partial fraction decomposition, right? Okay, so I will start the partial fraction decomposition procedure. You have x minus 2 over x squared times x plus 1. Right, I factor it right away. So it will be something over x plus something over x squared plus something over x plus 1. Multiply by the LCD. So we get x minus 2 equals to ax times x plus 1 plus b times x plus 1 plus c times x squared. And the LCD is x squared times x plus 1. Now then from here I said let x equals to 0. It will be negative 2. This is 0 plus b plus 0, which means b is negative 2. When x is negative 1, negative 1 minus 2 equals to 0 plus the second term is 0 plus negative 1 squared times c. So negative 3 equals to c.
I have a question.
Uh-huh.
When would we know what, I mean, I know it's from experience, but like from looking at it,
That's the answer. You need to have some experience to know when to use what. But usually here is this, if you have like, you see that your denominator, you have x squared, x minus 1, right? So if you choose x equals to 0, this term will disappear, this term will disappear when you choose x equals to 0.
right?
Okay, so your question of when do we know requires some experience. And when you try to experience that, you also need to think. Okay, it is impossible for you to know it without thinking. Okay, so when you think about it, okay, if I set my x equals to 0, this guy disappear, and I get something in terms of b only, right? If I set my x equals to negative 1, then this guy will be 0, because this is 0, right? And this guy will be 0, okay? And I have something in terms of c only. Now, the thing is we have only 2 special numbers here, right? Only 2 special numbers. So the third number, I still can choose numbers. I can choose x equals to 1 if I like, okay, to find the a. Let me do so. When x equals to 1, I get 1 minus 2 equals to, this is a times 1 times 2 plus b times 2 plus c times 2 squared. I'm sorry, c times 1 squared. So this is negative 1 equals to 2a plus 2b plus c. Now then you do substitution. The b is negative 2, the c is negative 3. So this is negative 1 equals to 2a minus 7. 6 equals to 2a, so a equals to 3. So that x minus 2 over x squared times x plus 1 is now equals to 3 over x minus 2 over x squared minus 3 over x plus 1. Now, if I integrate this, that's the same to integrate this. Okay, by the way, the last number x equals to 1, you may be able to get, there's other method, you can use other method. For example, here, you see that the x squared term on the left-hand side, the coefficient is 0, like we have 0x squared, right? Okay, so the left-hand side is 0. The right-hand side, you have ax squared plus cx squared. Now we know the c is -3. So from there, we can see a equals to 3. That's just another way to do that. Okay, so you do the term-by-term comparison. Now go back to this original question. I will continue, but this is just to integrate. This is 3 natural log of absolute x. What will this be? It's positive 2 over x minus 3 natural log of absolute x plus 1 plus constant. Okay, and that should be okay if you leave it like that. Now, sometimes you may want to combine the natural log. So this is 3 natural log of absolute x over x plus 1 plus 2 over x plus constant. That's also okay.
In this situation, we don't have to prove that the ln, the absolute value, is positive or negative.
Repeat it again.
In this situation, whatever's inside the absolute value, we don't have to prove that it's positive or negative.
Well, because you use absolute value.
Yeah, but aren't we supposed to solve for inside the absolute value or no?
When did we do that?
When you're doing indefinite or values integrals.
Yeah. Well, basically x and x plus 1 may be positive, may be negative. So just keep it absolute.
Oh, okay.
If you have a natural log of absolute x squared plus 1, then x squared plus 1 is always positive anyway. So you don't need to use that absolute value. You can just change it to parentheses.
Okay. I was just wondering, because of the whole points thing, like if it matters that we have to put it in the parentheses and prove that why it's in the parentheses.
Actually, not really proof that. It's more about like if you see something that you don't need absolute value, then don't need to use absolute value. You know. Okay. But it's like to say that you need to prove sounds like you need to like show a lot more work to show that it is always positive, right? But actually, no, you don't need to prove that as that. You just look at that as x squared plus 1, for example, then that's always positive, right?
Yeah.
Okay. Any other question you want me to do first? Otherwise, I go to question number 2. Okay, I go on instead of waiting. Partial fraction decomposition again. We have on the top, we have 2x squared plus x minus 1 over x cubed minus 3x squared plus x minus 3. And then I make a note there that you need to know how to factor the denominator, okay? Because I think that's actually quite standard. I have students, however, they don't know how to factor it. And let me tell you this, if you cannot factor it by the time you have your test to drop the class, okay? I don't know what's wrong with your Algebra 1, Algebra 2, trigonometric and pre-calculus and calculus 1 teachers, like 4 teachers back to back, let you pass without knowing how to factor by grouping. Something really wrong with those 4. Okay, no, you're supposed to know already at this point when you see this question how to factor it. Okay, now I cannot forgive your teacher, not only you. I cannot forgive your teachers. How can you pass those classes without know that? I mean, the reason I mentioned this because when I gave this question in the test, okay, I think this is the second time I give the question. Okay, so the first time I gave that, I have a plenty of students ask me, Thomas, you didn't teach us how to work on this kind of polynomial. I said, what? It's like, come on, man, that's something even Algebra 1 students supposed to know what to do. Okay, so the second time I gave this question, I gave this kind of like note, and some students still say, how can you expect us to know that? It's like, hey, you expect too less from yourself. Okay, you're supposed to know that. Okay, now, but anyway, that's 4 terms, right? 4 terms. So you should be able to first think, oh, you know what? Let me try factorization by grouping. It's not even polynomial that is kind of ugly that you see in pre-calculus though. No, I'm not talking about like, for example, 3x to the 4th plus 7x squared minus 2x and then minus 8 like that. No, this one you need to use some technique, okay, from pre-calculus, which I can actually enforce that on you. But no, I'm not that crazy. Okay, at least I'm crazy enough, but I don't even demand you to know pre-calculus, put it that way. Okay, when it comes to factoring, just basic factoring from Algebra 1 is good enough. But if you can't do Algebra 1 factoring, you don't belong to this class. Okay, sorry for being that harsh, but I think it is also rude if you think you can survive this class without knowing how to do factoring. Okay. Now, so the denominator I do by grouping x squared times x minus 3 plus x minus 3. Oh, so then on the top, I will get 2x minus 1, x plus 1 over x minus 3 times x squared plus 1. Actually, I don't need to factor the top. I just need to factor the denominator.
Wouldn't it be x minus 3 squared?
No, it's not. Okay, so I will break it up to be x minus 3a over x minus 3 plus x squared plus 1. That's degree of 2. So on the top has to be degree of 1. Then multiply by the LCD. We get 2x squared plus x minus 1 equals to a times x squared plus 1 plus bx plus c times x minus 3. The special number x equals to 3. So 2 times 3 squared plus 3 minus 1 equals to a times 3 squared plus 1 plus 0. 18 plus 2, that's 20. This is 10a. Therefore, a equals to 2. You can try other numbers if you like. Like for example, when x equals to 0, what happened? You know, when x equals to 0, let me try. When x equals to 0, then on the left-hand side is -1. On the right-hand side, we get a plus c times -3. The a is 2. So -3 equals to -3c, therefore c equals to 1. How to get the b's, we can see here the x squared term on the left-hand side have coefficient 2. On the left-hand side for x squared term has coefficient 2. On the right-hand side is basically ax squared plus bx squared, no other way. So that's a plus b, but we know what a is. A is 2, so b must be 0. In other words, that integral of 2x squared plus x minus 1 over x cubed minus 3x squared plus x minus 3 dx is now equal to integral of 2 over x minus 3 plus 1 over x squared plus 1 dx, because the b is 0. Therefore, this is 2 natural log of absolute x minus 3 plus, what is the integral of 1 over x squared plus 1? Anybody remember?
Sine inverse?
Huh?
Sine inverse?
What inverse? What inverse?
Sorry, I think it's sine inverse.
No. Tangent inverse. Okay, you need to memorize that though. Okay. Yeah. Integral of 1 over x squared plus a squared dx. That's from your test 1, by the way. You're supposed to memorize that even from test 1. It's 1 over a tangent inverse of x over a plus constant. And then for sine inverse is actually 1 over square root of a squared minus x squared dx. That's sine inverse of x over a plus constant. Okay, yeah, but please memorize that. That's for number 2. Again, do you have any question you want me to go over beside going through number 3 right away? No question. Then I go to number 3. Integrate this. Wow, I give you a hint. Note the complete the square. So this is equal to integral of 2x plus 1 over x squared minus 2x plus 1 plus 1. It's x minus 1 squared plus 1 dx. Oh, u-sub. So let u equals to x minus 1, du equals to dx. So on the top, there will be 2 times u plus 1. Well, because x is then u plus 1. Plus 1 over u squared plus 1 du. But that is integral of 2u plus 3 over u squared plus 1 du. I will separate them. This is integral of 2u over u squared plus 1 du plus 3 times integral of du over u squared plus 1. Now, if w equals to u squared plus 1, then dw is 2u du, right? So this is integral of dw over w plus 3 times, oh, this is tangent inverse u. Oh, I don't need to plus constant. I still have integral there. This is natural log of w, absolute of w, plus 3 times tangent inverse of u plus constant. Now I will put everything back. What is my u again? X minus 1. And u squared plus 1 is, that's always positive, so I can just use parenthesis, but that is x squared minus 2x plus 2. That's for number 3. Number 4. Oh, I think this one is a hard question. I remember last semester I happened to ask one very hard question. It is 0 on the denominator when x equals to 0. X equals 0 is a singular. It makes it undefined. We call that singularity. Okay, so I need to break this integral up. An integral from -1 to 0 of x to the power of -1/3 dx plus integral from 0 to 8 x to the -1/3 dx. And then limit t goes to 0 from the left-hand side, integral -1 to t x to the power of -1/3 dx plus limit s goes to 0 from the right-hand side, integral s to 8 of x to the -1/3 dx. Yeah, this way we do not put x, replace x by 0 and give us undefined. Okay, it is singularity at 0, right? If you plug in x equals to 0 there, then it is singularity. We cannot. We have to approach that using limit. So this is limit t goes to 0 negative of 3/2 x to the power of 2/3 from -1 to t plus limit s goes to 0 positive of 3/2 x to the 2/3 from s to 8. Then from here, when we plug in t equals to 0, let me plug that the t into the x first. So that will be 3/2 t to the power of 2/3 minus 3/2. I write it down. Plus 3/2 8 to the power of 2/3 minus limit s goes to 0 positive of 3/2 s to the power of 2/3. Okay, now the first term here is 0. This is 3/2 plus 3/2 times, what is 8 to the power of 2/3 without using calculator? It's 4.
3 to the power of 2/3.
8 to the power of 2/3 means you do the cube root of 8 first, and then you square it. Okay, let me erase that. Now then, when we compute this further, this will be 9/2. That's for number 4. Number 5, oh shoot, this one is bad. That's so the issue only here. The issue is only there. There's no singularity in between. Okay, then this is equals to limit t goes to infinity of integral from 0 to t of x times e to the negative x dx, integration by parts. Give us limit t goes to infinity of negative x e to the negative x minus e to the negative x from 0 to t. You know what? Let me factor the negative out. So I get x e to the negative x plus e to the negative x. Now you don't need to factor that negative though. I just don't like negative laying around there.
Can you factor out the e to the negative x?
Yeah, you can, but you cannot factor it out all the way to the left of the limit.
Right.
Right? Yeah. But yes, you can if you want to. So this is t e to the negative t plus e to the negative t minus, when x is 0, that will be 0 plus 1. So this is negative limit t goes to infinity of e to the negative t times t plus 1, and then plus 1. Right? It becomes plus because of this negative with this negative here, give us this positive. Now then, when I plug in t to be infinity, this is 0, but this is infinity. That's indeterminate. So I need to play around. This is negative limit t goes to infinity of t plus 1 over e to the t plus 1. And then apply L'Hopital rule. Long time no see, but you need to know that. That's negative 0 plus 1, that's equals to 1. Okay, that's for this question here. Number 5.
Sorry, when you apply L'Hopital rule, would you apply it only to t plus 1 over e to the t, or also plus 1 to the right?
The limit here only applies to this part.
Oh, I see. Okay.
Yeah, if it applies to 1, then I will put it this way.
Okay.
Right? But even if I put 1 there, that's actually, there's no variable there, so there's no need to compute the limit, right? The limit of 1 is 1.
Yeah.
Right? Because it has no variable. Okay. Yeah, but no, that one is without parentheses, so the limit actually applies only to that fraction, but not to the 1.
And the negative to the left, you had already eliminated it, or did you?
Repeat again.
That negative to the left, you had already eliminated it, right? So it shouldn't be there, or it should be there still?
It is there. So this negative applied to this. That's what it looks like. And then
Oh, I see.
this negative applied to that, give you this.
Okay, cool.
Okay, now number 6. Let the curve C be this. Set up the integral to represent the length of curve for C from x from 1 to 4. Okay, so the y prime is 2/3 times 3/2 times x squared plus 1 to the power of 1/2 times the derivative of x squared plus 1. That is x squared plus 1 to the power of 1/2 times 2x. So y prime squared is x squared plus 1 being squared becomes to the power of 1 times 2x being squared. That's 4x squared times x squared plus 1. Now, then 1 plus y prime being squared is 1 plus that guy. Let me distribute that. Oh, but this is actually 2x squared plus 1 being squared, such that the square root of this, notice that I don't touch the integral at all. Right? I focus more on the integrand. The formula for the length of the curve will be integral from a to b square root of 1 plus y prime squared dx. Right? Okay, now I simplify all the way the integral first. Now the length is from 1 to 4 of 2x squared plus 1 dx. That's the setup. Now, plenty of students during that time, they rush through this. They don't even, I don't know, it's like, to be honest with you, yesterday in the math department meeting, I brought up this issue that a lot of you not doing well in your test one.
Yeah.
And if you get like around 50s, maybe you are not prepared for the test. But if you get around 20s or less, even 30 or less, either you don't study at all, and your foundation from Calculus 1 is really bad. So I brought it up. I say, I don't even want to know who taught Calculus 1 last semester, but you did a very terrible job. You know, it's like what happened is like, it's like this. Expecting too less from your student it's degrading. You look down on your own student. No, give them the actual calculus students, not Mickey Mouse calculus. Because what? Because if I don't teach you right in calculus 1, or in my case here, if I don't teach you right in calculus 2, I basically disabled you from passing whatever class where calculus 2 is a prerequisite. You see, it sounds really wrong, but that's what actually happened. If I try to be too nice to you, okay, and such that you don't learn what you're supposed to learn, then you will never learn that anymore. It's like, if you don't know how to do factoring, I will not teach you factoring. Okay, that's not my job. Okay, and I refuse to do somebody else's job, especially if I do that person's job, that person get the credit, I don't get the credit. Right? There's nothing nothing to be proud of to teach somebody factoring at calculus 2 level. Okay, so let's set things right. Either you don't study hard enough, or your calculus 1 teacher's not doing a good job and just let you pass. Okay, I know who is that person. Okay, but I didn't mention that in the math department. I don't need to mention that here. You guys supposed to actually talk to that teacher. Why you let me pass while I'm not supposed to pass? But no, I have seen people, not precisely like this, but I have seen people doing this thing. Integral of x squared dx. Somebody did it this way. Integral of x dx times integral of x. It's actually x cosine x. And that person do it this way. What the heck? It's like, that's clearly integration by parts, but this person is just like, no, this is not integration by parts, it's that easy. I learned it in my calculus 1. I was like, it's like, I want to write a lot of things on that paper, but I just like, nah, you know what? I don't need to hurt myself. Okay, but that's when I saw that, I was like, what What did your calculus 1 teachers doing to you? Remember, if this were true, integral of f times g dx, if this were true, then we don't need to learn integration this hard. Just integrate them one by one, right? And then multiply the product, multiply the integral. The integral of product equals to the product of integrals. But that's not true. It is not true. Even the derivative is not true. Like, you see, the derivative of f times g is not f prime g prime. You know that. Right? You need to do product rule. And what makes you think the integral will be like that? No, it's not. Of course, I would like you to attempt when you see a problem that you don't know what to do, but I don't want you to attempt it in a way that it's like, oh, man, you don't even call this attempt. You're just like embarrassing yourself. Oh man, I'm sorry, but when I saw that, I have to slow down when I grade your test. Like I need to, if I get pissed off, I have to stop. I need to walk away. And once I cool down, then I continue grading it again. That's why it takes so long. At the same time, the students from Santa Monica, I caught a lot of them actually use photomath. Not knowing that photomath, you heard photomath before, right? You may even use that in the past. Okay, photomath has a very, very big weakness. It cannot do the root odd index radical for negative number. So for example, if you put in cube root of -8, it will call that undefined. It will call that undefined. I mean, I don't know why, but I saw students actually use this, like -64 to the power of -2/3. They call that undefined. I was like, no, that's not undefined. That's not undefined. That's a positive number. You can just compute it. I mean, I'm telling you this with my pre-calculus class at SMC. Too many of them use photomath without realizing photomath has very, very big weakness. And not only that, though, plenty of stuff there. Photomath, you go to your Google app, the Play Store, Google Play Store, and then you get Photomath. It's basically an app. Yeah, it's basically an app that if you take the picture of the question, it will show you the work. But I warned them many, many times. So in my class, don't use that. In my class, don't use that. They still use it. Well, anyway, let's come back here. Part B, integrate the result from part A. Now, once you are done, my purpose is I want you to focus on the setup and do the integration later on. Okay. Now, part B, if you have that setup already, if you don't know how to integrate this simple polynomial, then go back to your pre-calc 1 teacher and then yell at him. Okay, or maybe you just forget it. You forget how to integrate, but not supposed to do. I think this is way too easy to do. Okay, so this is 2/3 times 64 plus 4 minus 2/3 plus 1. That's 2/3 times 63 plus 3. So what's that? 21, 42, 45. That's for number what? Number 6, I believe. That's page 6, right? Number 7. This is the curve y equals to x cubed. Set up the integral to represent the surface area of x-axis revolutions. So let's say I have this curve here from 0 to 2. And let's say this is my ds. I revolve that around x-axis. So my radius will be y. My radius will be y. So the formula will be, I don't remember the formula precisely, but after that I see, oh, then the surface area will be the summation of 2 pi radius, right? 2 pi y ds, right? That's the big formula. Now then that will be from 0 to 2, the y will be x cubed ds square root of 1 plus y prime, that is 3x squared being squared dx. That's the setup. Let me slow down. Let me slow down. Okay, so we know the radius is y, which is x cubed. Now how about the ds? The ds is square root of 1 plus y prime squared, where the y prime is 3x squared. So I'm sorry, this is with dx. So ds will be square root of 1 plus 3x squared being squared dx. So the surface area is the integral from 0 to 2 pi radius ds. Now how to integrate that? Surface area equals to integral from 0 to 2. I pull the 2 pi out, x cubed square root of 1 plus 9x to the 4th dx. Any suggestion how to integrate this?
We can do u sub first.
What is the u sub then?
1 plus 9x4, 9x to the 4.
Okay, so du equals to 36x cubed dx. And then u0 is 1, u2 is, oh, what's that? 16 times 9. 1 plus 9 times 16, 145. So now the integral becomes 2 pi integral from 1 to 145 u to the power of 1/2 du over 36. That is pi over 18, 2 over 3 u to the power of 3/2 from 1 to 145. So that's pi over 24, 145 square root of 145 minus 1. That's for number 7, number 8. Set up the integral that represent the curves of surface area revolution around y-axis. Oh, but the curve is the same, huh? So the curve, so y prime is still 3x squared. Let's say this is the curve, and this is the ds. But when you go around the y-axis, the radius will be x. Okay, the radius is x. Okay, so give me a second. So y prime squared is 9x to the fourth. If I add 1, it will be plus 1. So the ds will be square root of 1 plus 9x to the fourth dx later on. Okay, the surface area will be integral from 0 to 2 pi radius square root of 1 plus 9x to the fourth dx. That's the setup. How to integrate this? Any plan how to integrate this? I think I will change that 9x to the fourth to be my u squared. I mean 3x squared equals to u. So that later on we have square root of 1 plus u squared. You see what I mean? But if u equals to that, then 6x dx equals to du. So now we get 2 pi integral. Oh, when x equals to 0, u is 0. When x equals to 2, u is 12. Okay, this is square root of 1 plus u squared du over 6. This is pi over 3 integral from 0 to 12 square root of 1 plus u squared du. Okay, tell me what to do. U equals what?
3x squared.
No, I know, but to integrate this, what you will substitute u by?
Oh, 1 plus u squared.
Yeah, tangent theta.
Oh, tangent theta. Oh, sorry.
Du equals to secant squared theta d theta. So now this is pi over 3 integral. When u is 0, theta is 0. When u is 12, this is tangent inverse 12. Square root of, so this becomes secant theta times secant squared theta d theta. So this is pi over 3 integral 0 to tangent inverse 12 secant cube theta d theta. Now this is one important integral I ask you to memorize, or at least you have that next to you on your cheat sheet maybe.
Is that 1/2
Secant tangent and then
plus ln 1/2 ln
that's from 0 to tangent inverse of 12. Okay, but let's do the triangle first, and then it's easier for us to substitute. If this is theta, tangent theta equals to u, right? So this is a u1. This is square root of 1 plus u squared. Then secant theta is square root of 1 plus u squared, right? Tangent theta is u, okay, plus 1/2 natural log of secant theta is square root of 1 plus u squared plus u. And now we go back to u, that's from 0 to 12. Plug in 12. So 1/2 square root of 145 times 12 plus 1/2 natural log of square root of 145 plus 12. Minus when u is 0, that's 1. I mean, just 0. So this is 6 square root of 145 plus 1/2 natural log of square root of 145 plus 12. That's for number 8. Sorry, too far. Number 9, we have this lamina bounded by y equals to x cubed and square root of x. Find the mass. So the mass equals to, it's constant density, right? So the mass will be rho times the area, basically, right? So rho times integral. Where do they intersect?
From 0
X
to
cubed equals to square root of x. So square both sides. X to the 6 minus x equals to 0, factor the x. So either x equals to 0 and x to the 5th minus 1 equals to 0. That x equals to 1. So the intersection are when x equals to 0 and when x equals to 1. We can see that actually there, right? There should be two intersections. Now then, the area, will there be a situation where there isn't constant density? Yes, you will see that in calculus 3. You will see that in calculus 3, okay? So at that, in calculus 3, your rho will be a function of x and y. Now, if that's the situation, then you cannot pull it out like what I did here. But because in this case, it's constant, right? It's independent of any variable, right? Okay, now the area will be, what is the function on the top? The function on the top is square root of x minus the function at the bottom in that region is x cubed dx. Integral from 0 to 1, x to the power of 1/2 minus x cubed dx. This is rho times 2/3 x to the 3/2 minus 1/4 x to the 4th from 0 to 1. The things I like about polynomial from 0 to 1 is you basically just add the constant. So that's 5/12 rho. Don't forget the rho. Don't forget the rho. How about m, the moment with respect to y-axis? The moment with respect to the y-axis is the same setup, exactly the same setup, but you insert x. Okay, because let's say this is the curve, right? Okay, Now, the moment with respect to y-axis is that function multiplied by the distance from the y-axis, which is x. Okay. So moment with respect to the y-axis, you insert x. So this is rho integral 0 to 1 x to the power of 3 halves minus x to the 4th dx. This will be equals to rho times 2/5 minus 1/5. That's 1/5 rho. Then part C, find the moment with respect to x-axis. M sub x equals to 1/2 rho integral 0 to 1, the function being squared. So square root of x being squared minus x cubed being squared dx. That's 1/2 rho integral 0 to 1 of x minus x to the 6 dx. That's 1/2 rho 1/2 minus 1/7. That's 5/28 rho. So that, is there any question down here? What is the y bar? The y component of the centroid. Y bar is moment with respect to the x-axis over the mass. That is 5/28 rho over 5/12. The rho cancel, the 5 cancel, that's 12/28 reduced by 4, that's 3/7. That's for number 9. Number 10, let the lamina D be triangle with this density, this vertices with this constant density. Find the mass of D. You know what? Let me draw it first. That's 0, 0, 0, 9. And actually, that's incorrect. And then 6, 3. 6, 3. Find the mass. The mass, remember this is a constant density, so this is actually rho times area, right? That's rho times 1/2, 9 times 6. I wonder if you understand what I'm doing here. It's base times height, right? Let me make my base here. The length here is 9 and the height is 6. Right? That's the area of the triangle. Now, of course, if you want to work hard, you do integration, right? Now, some people like to work hard though, I understand. So you may want to do that's the first method. The second method, you may say the mass is equal to rho times integral from 0 to 6. And then the upper function, this is, can you tell what's the slope? This y equals to negative x plus 9. And this guy here, y equals to 1/2 x. So the top function minus the bottom function. Okay, let me answer that later on, Shane. Okay. And this one is, let me finish this question first. This is rho times integral from 0 to 6, negative 3/2 x plus 9 dx. That's rho times negative 3/4 x squared plus 9x from 0 to 6. That is rho times negative 3/4 times 36 plus 54. So that's 27 rho. Okay, but there's a good thing that we actually do the integral. Okay, when we do the integral, set up the integral here, because we need that in part B though. Find the moment about the x-axis. Moment about the x-axis. This actually can be done in two different methods. I show you both methods. Okay, the first one, the standard way. The standard way. That's rho times integral from 0 to 6. 1/2 the top function squared minus the bottom function squared. That's the setup. So this is 1/3 x. You know what? Yeah, I integrated right away. So this is 9x squared plus 81x minus 1/12x cubed from 0 to 6. The thing is, I supposed to combine like terms first. Yeah, I supposed to combine like terms first here. And then it will be a lot easier for me. Well, anyway, I did it already. Fine. Let me see. I have a chat coming in. Now then, I plug in numbers. I use green. So 36 times 2, that's 72, minus 36 times 9, plus 81 times 6, minus 3 times 6, 18. Now let me use calculator for this. 72 minus 36 times 9 plus 81 times 6 minus 18. So this will be 108 rho. Now this is the first method. Notice that the way I did it was, I did this way. So I take this guy here, okay, and I revolve that around x, right? Whose distance is actually 1/2 y. Okay, but there's another way though. There's another way to do this. I'm not sure if that will be easier, but another way to do this is looking at that from y point of view. So from y point of view. So this is y. Instead of seeing it that way, we see it this way. Okay, so the equation here, for example, this is y equals negative x plus 9, right? You can write that as x equals to negative y plus 9. The one here, y equals to 1/2 x, you can write that as x equals to 2y. Now, the moment with respect to x-axis is equals to rho times integral from here to here at 0 to 3. Okay, so when you revolve, when you try to find the moment with respect to x-axis here, 0 to 3 of y times 2y dy plus rho times integral from 3 to 9 of this. That's negative y plus 9 times y dy. So basically, the original graph that you looks like this, right? Let's say this is side A, this is side B, and this is your x-axis, this is your y-axis. You switch them to be something looks like this. And you rotate around x-axis. Okay. Now it consists of two parts here. This is the first part, and that's the second part. So if you integrate this second way here, you will get the same result. I mean, supposed to be. Okay, let's try. So this will be 2 over 3y cubed with rho from 0 to 3 plus rho times negative 1/3 y cubed plus 9 over 2y squared from 3 to 9. That's 18 rho plus, I don't know what's that. You can compute it yourself. Okay, but that's another way to look at that. Okay, that's another way to do that. Look at that. Let's see part C. Find the x bar. That is the x component of the centroid. Now to find the x bar, I need to first find the moment with respect to the y-axis divided by the mass. Okay, now the moment with respect to the y-axis will be integral from 0 to 6 x times negative x plus 9 minus 1/2 x dx. Let me simplify the guy inside the bracket first. So that's x times negative 3/2 x plus 9. So that will be 2, 3. So that's negative 1/2 x cubed plus 9 over 2x squared from 0 to 6. Negative 108 plus, what is 18 times 9? 81, 162. So that will be 54. Okay, so x bar equals to 54 rho over 27 rho. That's equals to 2. I would like to do this problem another way. I want to do this problem another way, but it requires a little more extra explanation, which I did when I in their class. So if you watch the lecture I gave them, I actually mentioned that if you have a triangle, then the center of mass is actually the average of the vertices. So you can do x bar is by just adding the x component of the first coordinate, the x component of the second coordinate, plus the third component, the x component of the third coordinate divided by 3. Bang, you are done. Okay, nobody but one student in that test actually used this method. Okay, Shane, I'm about to go back to you, but let me copy this page. Give me a second. Let me copy this page and show you an alternative to do this problem. And this was presented by one student. Trust me, I was so happy when I saw somebody actually use this method. I mean, I myself didn't realize that you can do that. Yeah, I myself didn't realize that you can do that. Hold on, I need to insert. So for number 10, I will redo it. Okay, number 10, redo with extra knowledge that the x bar, y bar of a triangle is given by x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. Okay, so for part C, that person can just say x bar equals to 0 plus 6 plus 0 over 3, that's 2. End of story. That's his 4 points. And the mass of that lamina D is equals to rho times the area, which I did earlier, right? That's 1/2 times 9 times 6, that's 27 rho. Now, that student surprised me with his way of doing part B. Moment with respect to x axis over mass equals to y bar. But at the same time, we know y bar is y1 plus y2 plus y3 over 3. Now, then the moment with respect to x-axis will be the mass, which is 27 rho times y1, y2, y3, 0, 3, 9. 0 plus 3 plus 9 over 3. That's how that student did it. And when I saw that, I was like, oh, wow, what the beep? You know, I mean, to be honest with you, I think I'm a quite tricky person, right? I did a lot of problems that, I mean, I will be aware with the shortcut, but I guess I didn't realize that we can actually do it that way. So this question suddenly becomes so easy for that one student, for that one student. I mean, I am aware with A and C, part A and C, but I just didn't realize that, yes, you already have the mass from part A. You just use that because you know the Y bar anyway. Okay, yes, that's our hero. That's our hero. Okay, that's for number 10. Now let me go to Shane first. Shane, you have question from the quiz, you say?
Yeah, real quick.
Uh-huh.
For number 6, you asked us to set up the integral. On the quiz, sorry.
Give me a second. Let me find
no
out the file first.
Of course.
That's from Spring 21 quiz 678.
678, correct.
Mm-hmm. And which question?
Number 6. I'll let you pull it up. So a few of us were working on this, and we set up the integral, but we also solved it. Now, I didn't circle the integral or anything, but does that matter too much for you?
No, I just want to see the setup.
Okay, so when
Yeah.
you say setup, did you want to see like how we got the depth and how we got the width, and
Yeah, of course, yes.
and then the x where we put the x equals 0 relative to that? Okay, sweet.
Yeah. So if you actually there are 3 or actually 4 different ways to attack this problem. Yeah, there are 4 different ways to attack this problem. Let me tell you first that, but all I need you to do is actually to set up. Show me how you get the depth. Where's your x, right? The reference line,
right?
Your x, your depth, your length. But the first one, of course, your x can be here. Another one, your x can be here. Another one, your x can be here.
Correct.
Okay, there are 3 different ways to do this. Plus, another one is you basically assume this triangle is actually on the surface.
Oh.
And then you sink it down by 7 meters.
Oh, which you showed us.
Yeah, the shortcut way.
Yeah. Okay.
But that's more into to help you with your computation, actually.
Of course.
So not really with the setup.
So I already submitted my quiz. I'm wondering if I should resubmit it because
you can before the deadline. Before the deadline, you can resubmit it.
Okay. I put what the width is, but I didn't show how I got the width. And you would like to see that, correct?
Where's your reference line?
X equals 0 at the water surface.
X equals 0 at the water surface. So
at the way top.
It's actually quite easy to see. So I assume your width will be x minus 7.
Correct.
That's okay. Just leave it like that.
Okay. Okay. That's all I wrote. Perfect. Thank you, Thomas.
I purposely use the isosceles right triangle. So basically the length here is the same to the length here. I tried to make it easy for you. This was a test question. This was a test question. So I just need those know how to set it up. Once you know how to set it up, the integral is Mickey Mouse. I don't even want to see it.
I mean, I already put
but that's okay. Don't worry about it. So yeah, but when it is a circle, for example, semicircle, right? Or if you have parallelogram, I'm sorry, trapezoid, for example, I would like to see that. Okay, and that should be in your test, though. That's the case for your test.
Understood. Thank you, Thomas.
Sure. Okay, so that question, I actually get it from here. I turn this triangle like 45 degrees. No, actually, yeah, how many degrees? 135 degrees to the left, counterclockwise. And then I change this 10 feet becomes 12 feet. Then I get that question. Okay, this number 10, set up the integral such that so basically this is the graph, right? Now then what will my reference? I think I want to make my reference line here. Let's say this is my x equals to 0. Actually, this one is also good if you do it here. That's another choice. Yeah, I use the second method. You can go either way, but my point is if that's my reference line, then if this is x, what is the width? Right? For depth equals to, oh shoot, this is ugly though. If this is 5, then this will be 5 over radical 2. Ah, okay. For the depth, 10 minus 5 over radical 2 plus x. So this is 10 minus 5 over radical 2 give me this guy. So the depth will be plus that x, right? Okay, but if this is x, this will be 2x. Agree? The width is 2x. Now then, my hydrostatic force will be rho g. Do I use rho or density? Is there any? Okay, then I use, yeah, density rho. I use rho of the water times g integral from 0 to 5 over radical 2. The depth is 10 minus 5 over radical 2 plus x. The width is 2x. That's dx. And that's the setup. That's the setup. And then integrate that. Okay, let me copy paste that first. Why is there? That's not what I want. I want it here. Okay, now then, is there any better way to integrate that? That's rho g integral 0 to 5 over radical 2, 20 minus 5 radical 2 times x plus 2x squared dx. I may be thinking too hard. Yes, I will post this. So this will be 10 minus 5 over radical 2 again. I can just integrate that right away. Duh. That's x squared. No more integral. Plus 2 over 3x cubed from 0 to 5 over radical 2. Times 25 over 4 plus 2 over 3, 125 over 2 radical 2. Yeah, basically compute from there. Rho g, what is this? 125 over 2 minus 125 over 4 radical 2 plus 125 over 3 radical 2. Do I make a mistake? No. I factor 125 out. Oh, and then 1/2 minus, actually plus 1 over 12 radical 2. 6 radical 2. What am I doing? So that's 1/2 plus radical 2 over 24. So times 12. 12 plus radical 2 over 24. Okay, last question. The semicircle has radius 0.2. So let me enlarge that. So if my line of reference is at the bottom, x equals to 0, and this is my x, then this is 0.2. So this will be square root of 0.2 squared minus x squared, and then the whole length will be 2 times. So the depth will be 3 minus x, right? Because from the top of the water, this is 3 meters. If this is x, then this will be 3 minus x. Right? The width, however, or the length of the strip, let me use L instead. That's what I used before. The length of the strip will be 2 square root of 0.04. I leave it 0.2 squared minus x squared. So the hydrostatic force will be integral rho g integral from 0 to 0.2 3 minus x times 2 square root of 0.2 squared minus x squared dx. This is rho. Oh, I'm done with the setup. Maybe I clean up a little bit. 0.2, 2 times 3 minus x square root of 0.2 squared minus x squared dx. That's the setup. And how to integrate. That's rho g integral from 0 to 0.2. 6 times square root of 0.2 squared minus x squared dx minus 2 rho g integral 0 to 0.2 square root of x times square root of 0.2 squared minus x squared dx. This is 6 rho g times the area of quarter circle. With radius 0.2 minus, and I do substitution here, u equals to 0.2 squared minus x squared. So the du will be negative 2x dx. That is rho g integral. That will be 0.2 squared. This will be 0. And then 2x dx. That's negative du. That's u to the power of 1/2. This will be 0.06 rho g pi minus rho g times 2 over 3 u to the power of 3/2 from 0 to 0.2 squared. That's minus 2 over 3 rho g 0.008. Yeah, that's the answer. Multiply by 3, so 0.18. You know what? I factor the rho g. 0.0 multiply by 3, 0.18, not 0.18. 18 pi minus 0.016. That's the answer. I hope I don't make miscomputation anywhere, but yes, this is for 2020 test 2 solution. Yes, Robert? Yes, Robert? You don't understand where the 2 coming from in the length of the semicircle. Okay, let's go back. Let's see this one here. So in this triangle, this is one of the leg of the right triangle. This is the hypotenuse, right? Okay, so the length here is square root of that. But then I double it. That's how I get that. Yeah. That length here is only half. It's only half of the whole chord. Okay. Welcome. Okay, let me save this first. That's math 262, 03, 31, 21, 420, math 262, test 2 solution. Okay, I will take like around 5-6 minutes break. Right now it's 8:54. I will take like around 5-6 minutes break. I would like you to take a look on that 419 and choose some questions for me to do. Okay, because I don't have enough time to do all the problems. From here, I know I need 1.5 hours, right? And we have only 1 hour left, basically. So maybe choose some problems from that 419 that you want me to work on. Okay. Yeah, that way then I don't need to cover the questions that you can easily do. Okay, I post the solution already, the notes. Okay, so beside the recording, you also have my notes there. You can print it out and then try to do it on your own also. Let me give myself maybe 3 or 4 minutes break. And then at 9 o'clock, I will come back and do more problems. So for this fall 19 test 2, I have the request of doing number 7 and number 14. Let me see number 7. Okay, number 7, set up the integral that represent the length of curve C. So y prime is 1 over secant x times secant x tangent x, which is tangent x. So y prime squared will be tangent squared x plus 1 will be secant squared x. Oh, I'm sorry. I'm sorry. I'm sorry. So I'm sorry. Here. Thank you. Thank you. Thank you. So the derivative of that y is turns out to be tangent x. And then y prime squared is tangent squared plus 1 becomes secant squared. So square root of 1 plus y prime squared is simply secant x. Supposed to be in absolute value, but it will be positive anyway, since secant x is positive on this interval. So the arc length L will be integral from 0 to pi over 4 secant x dx. Now then, part B, what is the length? It's integral 0 to pi over 4 secant x dx. Integral secant is what? Natural log of secant plus tangent. So this is radical 2 plus 1 minus natural log of 0 plus, I'm sorry, 1 plus 0. So that's natural log of radical 2 plus 1 minus 0, just this. This for number 7. And then number 14, the drain with the shape of the circle with diameter 0.2 located at the bottom wall of a pool with 3-meter depth. Okay, so let's say this is the surface of the water and I will super enlarge that drain. I will set my reference line here. Okay, and let's say my x actually go in that direction. So this is my x. So my x will be from negative 0.2 up to 0.2, right? Now, if this is x, this is 0.2, then this guy here will be square root of 0.2 squared minus x squared. Is it right? Now, we know that the whole thing here is 3 meters. This will be 0.2 here. So this is only 2.8 meters. Okay, now if this is x, then this will be 2.8 minus x, right? So with that reference line, then the depth will be 2.8 minus x. The length will be twice of that square root thingy. And my x will be moving from negative 0.2 up to 0.2. So the hydrostatic force will be my x, I make it go upward, but if you want to make it go downward, that's also okay. Let's see. So another setup. Okay, so this is my x equals to 0. And let's say your x, you want to go this direction. Okay? You want to go to that direction. Now, this part here, up to here is 2.8. Is that right? Now, so the depth will be 2.8 plus x. So far, is it okay? But your x later on will start from x equals to negative 0.2 up to x equals to 0.2. If you want your x increase as you go further down. Okay, the length will still be the same. That will be 2 times square root of 0.2 squared minus x squared. So your setup later on will be the hydrostatic force will be rho g integral from negative 0.2 to 0.2. The depth 2.8 plus x times 2 square root of 0.2 squared minus x squared dx. While my setup will differ with yours here. Okay, now you may wonder, but Thomas, one is plus, one is minus. Why don't I expect that to be the same? Let's see, I expect that to be the same. As long as my setup is correct. Okay, as long as my setup is correct. So going back here, this is rho g integral negative 0.2 to 0.2, 2.8 minus x times the length. I'm about to show you why they will be the same. I will show you why they will be the same. Okay, but that's the setup first. That's 2 rho g integral negative 0.2, 0.2, 2.8 minus x square root of 0.2 squared minus x squared dx. Now let's mark it again. This is where we are different, right? Mine is minus, yours is plus. Agree, Robert? I'm not saying yours is wrong. I'm not saying yours is actually correct. Yours is also right. Now, you will see that when I try to integrate them, let me separate them first. Hydrostatic force, this is rho 2 rho g integral negative 0.2 to 0.2, 2.8 square root of 0.2 squared minus x squared dx minus 2 rho g integral negative 0.2 to 0.2 x square root of 0.2 squared minus x squared dx. Again, our difference is here, right? Yours is plus, mine is minus. But notice that this integral has symmetric domain, negative 0.2 to 0.2. And the function inside is an odd function. Okay, since x square root of 0.2 squared minus x squared is odd function, then the integral will be this integral here. The integral of odd integrand over symmetric domain is 0, right? So your plus and my minus doesn't matter. Okay, in the end, this will be just 5.6 rho g times area of semicircle. Okay. So if you look at yours, you will get exactly the same with mine. At the end, the setup looks different. Okay, the setup looks different, but when we actually integrate that, you will see that we come up with the same answer. Now, don't try to integrate this though. Don't try to actually integrate this. Please, please, you will waste so much time. Yeah, don't try to integrate this though. You know, because if you try to integrate that, you need to use usup. I mean, x equals to 0.2 sine theta, right? That's actually the only way. Oh, no, no, no. You can also do usup. But either way, yes, either way, it will take too long. don't do it that way. Okay, don't. By the way, I use my calculator to compute. This is 0.116 rho g pi. Other question? Is it okay, Robert? Okay, good. Okay, other question? So don't get scared if your setup look different from mine. So our difference is earlier, I have the same reference line with you, but my direction of x is going upward. Your direction of x is going downward. So our setup at the end may look different, but once we start computing it, we still come up with the same result. Okay. Other question? That's the last question here. Hey, that's your homework question. So now I don't do number 13. Okay. Done in quiz number what? 6, 7, 8? Oh, okay. Yeah, 6, 7, 8. Okay. Actually, I will not know if you ask me question for your quiz at this point. I don't even remember that. But is there any question that you find to be quite difficult? I think for the curve, center of mass, for these questions are actually okay. Not too hard. None of them hard, as I remember. It could be that this one is painful. Number 6. Is there part of your quiz? Let me see. If it's not, oh, number 3 in your quiz is hard. No, it's not. So let me do that problem. Yeah, let me do this one. Yeah, let me do this one. The thing is, this is an even function. Yeah, this is an even function. So the integrand is even. So you can say that's equals to 2 times integral from 0 to infinity of x squared over 16 plus x to the 6 dx. You can also break it up this way. So you say, oh, that's equals to integral from negative infinity to 0 plus integral from 0 to infinity You see what I mean? Okay, and then you do limit for each. Okay, now then this is 2 times limit t goes to infinity of 0 to t x squared over 16. Let me do it this way. This is x cubed being squared dx. So I do u sub. That's du over 3 and then 1 over 16 plus u squared. So that's 2 over 3 limit t goes to infinity 1 over 4 tangent inverse u over 4 from 0 to t cubed. So that's 1/6 times limit t goes to infinity of tangent inverse t cubed over 4 minus 0. Oh, okay. That's not too bad. So what is the what is the value of that limit? What is tangent inverse of infinity? Pi over 2? Okay, now if you do it with the method here, I believe you will get, if you use the method here, you will get pi over 24 plus pi over 24 in the long run. And the process will be very, very, very similar. Let's see. Yeah, we have this. The problem with this question here, number 5, which is part of your quiz, right? So I will not do it in full, but at least I want you to realize what's the problem. We have 2 problems. We have one problem here, but we have another one problem here because of this and because of this. You see? Not only because the interval involves infinity, but you also have singularity at the end of the left-hand interval. At the left end of that interval. Something like that, maybe, or maybe it has some bomb somewhere. So when you break it up later on, you integral from 0 to 1 maybe, plus integral from 1 to infinity, and you do limit t goes to 0 from the right hand side, plus limit s goes to infinity of that x to the negative 3 e to the negative 1 over x dx. And then you integrate one by one. And I think from there you need to do substitution first. You substitute the negative 1 over x or 1 over x, and then eventually you need to use integration by parts. Okay, other question maybe? So I think your integral later on becomes u e to the negative u negative du. Yeah, something like that. And then you separate them. Or you can integrate first using integration by parts. That's also okay. And then you split the limit of the limit. That's also fine. This one, complete the square. This one, complete the square. So do we have this question in your? Oh yeah, that's number one. Duh. Yeah, this is equals to integral 0 to 1 x over x squared plus 4x plus 4 plus 9. It should be easy for you at that point. This is not part of the test, right? Part of the quiz, right? Can I work on that? Yeah, that's not part of the quiz. So let's work on that. So that's x squared over common factor x minus 1, x squared plus 1. Oh, no fun. Don't forget to use parentheses here. So when x equals to 1, I get 1 equals to 2a. So a equals to 1/2. When x equals to 0, I get a minus c. So c equals to a, which is 1/2. And then the x squared term, on the left hand side the coefficient is 1, on the right hand side the coefficient is a plus b. So the p is equal to 1/2. Oh, wow. Life is full of 1/2. Yeah, right. So integral of x squared over that x minus 1 x squared plus 1 dx is equal to integral of 1. You know what? I'm so lazy. I just factor all 1/2 out all the way. Okay, so this is equals to 1/2 times natural log of absolute x minus 1 plus 1/2 natural log of absolute x squared plus 1 plus tangent inverse of x plus constant. Okay, let me just stop here. I'm tired. Let me give you maybe 1 or 2 minutes, just in case you have last minute question. Let me pause the recording.